Hello everyone, today I am going to explain about formation of the Pn junction.
We already know that how you can form an n-type semiconductor and p-type semiconductor. If you add dopants or impurities to the intrinsic semiconductor, that is pentavalent, if you add, that forms n-type semiconductor, and if it is trivalent, if you add impurity to the intrinsic semiconductor, that forms the p-type semiconductor. Okay, so here then how we can form our p-n junction. Okay, if you consider two materials, that is semiconductor material, one is n-type semiconductor and another one is p-type semiconductor. If you join together p and n-type semiconductors, then there will be a formation of p-n junction. Okay, so before that, what is the p-type semiconductor consist and what is the n-type semiconductor consist of? Okay, so the p-type semiconductor, you can observe here the diagram clearly. P-type semiconductor consists of holes are the majority carriers, and electrons are minority carriers. Okay, electrons are minority carriers, and at the same time we have acceptor ions will be there. Acceptor ions means negative ions, immobile ions we have. Okay, so here clearly I have represented here the p-type material and n-type material. Okay, the p-type material consists of holes that are circle here, and ions will be there, that is negative ions. Acceptor ions is nothing but negative ions, because they can always try to accept an electron and they become negative, more negative. So that's why these are called as acceptor ions. And here we have n-type semiconductor. N-type semiconductor consists of what? Electrons are the majority carriers, and holes are the minority carriers. uh, and at the same time positive ions, donor means what? If you add a pentavalent atom, what happened here? It will donate one electron, extra electron for the conduction, and it becomes positive. Okay, that is positive ion, it becomes positive ion. That's why these are donating the electron, and they become positive. Okay, so that's why these are called as positive donor ions that are present in n-type semiconductor, but negative acceptor ions will be present in a p-type semiconductor. Then how you can form a p-n junction? Okay, if you take two one p-type material and one n-type material, and if you join together both the n-type material and p-type material, there will be a formation of p-n junction. Okay, or another way is also there. If you consider an intrinsic semiconductor material, from one side if you dope with uh, from one side if you dope with trivalent atom, and from another side if you dope with the pentavalent atom, so that forms a p-n junction, or p-n junction in a single crystal. Okay, so here both ways you can form both ways you can form a p-n junction. That is, one is if you consider p-type semiconductor and n-type semiconductor, if you join them, so there will be a formation of p-n junction. And otherwise another way is also there. If you consider a single intrinsic semiconductor crystal of silicon, suppose silicon and germanium are semiconductors what we are going to use in our semiconductor devices. So mostly we are going to use here silicon. So that's why I am considering here to form a p-n junction. Let us consider an intrinsic semiconductor crystal, single crystal, and if you add from one side the trivalent, and from another side the pentavalent atoms, so where the trivalent atoms are added, that becomes p-type material, and where the pentavalent atoms are added to the crystal, that becomes n-type material. Then there will be a formation of junction. That junction is called as what? Then there will be a formation of junction between the p-type material and n-type material, that is called as p-n junction. Okay, I will show here in the diagrammatically here to you. So this is what how a p-n junction will form. Formation of p-n junction for us. How a formation of p-n junction will be done by taking n-type material and p-type material, and if you join them, then there will be a junction formed in between p and n-type material. That junction is called as what? P-n junction. Or otherwise another method is there, that is nothing but if you consider a single crystal of intrinsic semiconductor, for that one, from one side if you add divalent, and from another side if you add pentavalent, that is phosphorus, arsenic, antimony and bismuth. Okay, if you add them, what happen? where you are adding trivalent, that becomes p side, and where you are adding pentavalent, that becomes n side, so that there will be a formation of Pn junction in a single crystal. Okay, so that is what how you can form a Pn junction. Okay, you can see here the left side material is a p-type semiconductor having negative acceptor ions and positively charged holes. Okay, but here the right side material is n-type semiconductor having positive donor ions and free electrons. Okay, so here some minority electrons will be there in p-type semiconductor. In n-type semiconductor also we have the minority holes will be there, minority carrier concentration, because of the temperature increase, there will be a formation of whole electron generation will take place. Due to that, some minority carriers will be there in n-type semiconductor, and at the same time in p-type semiconductor the minority carriers are electrons. This one already we have seen in the extrinsic semiconductor. Okay, so you can observe here in an n-type semiconductor the concentration of electrons is more than that of the holes. Okay, on the other hand, in a p-type semiconductor the concentration of holes is nothing but majority carrier concentration, that is holes in p-type, is more than that of the electrons. Okay, right. So here then how you can represent the p-n junction means, here in this diagram I am showing that if you consider this one is the p region after and this one is the n region, if I join these two, here you can observe the yellow thing. Okay, here you can observe the yellow color. That color indicates what? That color or that region indicates the Pn junction. That is, junction means from one side one way is there and another side one way is there. They are meeting at a particular point. That is nothing but junction. Generally in our daily life we are what we are seeing the junction means. Similarly here we have a p-type material and an n-type region, and they are meeting at a particular point. That point is called as Pn junction. Whenever if you join p and n regions, then there will be a formation of Pn junction between p region and n region. Okay, so diagrammatically I can represent I have this diagram here. So this is p region and this is n region. Okay, out of this p region you can observe the white color or the holes that are majority carriers. Okay, white color are the holes that are majority carriers, and these are the pink color what we have with minus sign, those are called as electrons, that is minority carriers. Already I told that majority carriers are holes in p side and minority carriers will be electrons. Okay, similarly here we can have here majority carriers in n type is what? That is electrons, and minority carriers are holes. So here you can observe here it is sea of electrons. In between them we have a small number of holes will be there in n region, that is minority carriers. That's what this statement this statement gives. And in an n-type semiconductor the concentration of electrons is more than that of the holes is here minority carriers. Similarly you can write the same thing in p-type semiconductor. The electrons are the minority carriers and the holes are the majority carriers. Including this majority and minority carriers, we have another ions, that is charges we have, that is immobile ions. So we have negative acceptor ions. I'm not included here. I have just shown only the electron and hole concentrations in p region and n region respectively. Okay, but including these electrons and holes, that is majority and minority carriers, we have again in p region we have negative acceptor ions. In the n region we have positive donor ions. Okay, totally if you consider a p region, what we have, the majority carriers are holes, minority carriers are electrons, and acceptor ions, negative acceptor ions. Three charges will be there. If you consider n region, similarly the majority carriers are electrons, minority carriers are holes, and at the same time we have positive donor ions, right? So this is what how the junction is formed. Okay, so here if you take this one to the room temperature, okay, what happened here, there will be a movement of holes and electrons will take place. That is called as open circuit. Already we have formed a junction. Okay, this is how a Pn junction is formed for us. Okay, Pn junction is formed for us. Okay, after forming the junction, after formation of the Pn junction, next what we will do here, we will go for open circuit condition. We will study about the open circuit Pn junction. Okay, open circuit means what? We are not applying any voltages, any external voltages to that one. Just we will take that Pn junction what that is formed at the room temperature. Then what happened? We have to observe. That is nothing but the open circuit Pn junction, right? Here up to till now we have seen the formation of Pn junction. Now next what we have, we are going to observe the open circuit Pn junction. Okay, we are not applying any bias. Okay, this one is P type and this one is N type. I am not applying any external bias. Okay, external voltages or external DC voltages I am not applying. Just I am keeping my Pn junction at room temperature. So what happened, I have to see. Okay, I will explain that clearly. When a Pn junction is formed, so the Pn junction is formed, you can observe clearly P region and N region. Here we have the junction formed between P and N regions. Okay, so when a Pn junction is being formed, holes diffuses from P side to the N side. Holes means the majority carriers that will moves from P region to the N region. So why we are using here the diffusion term? Because diffusion is nothing but due to concentration gradient. Okay, if there is a concentration gradient, uneven concentrations of the charge carriers, at one place higher concentration is there, at another place lower concentration is there. Okay, then there will be a process takes place. That process is called as diffusion process of the charge carriers. Okay, so after formation of the junction, if you take that one to the open circuit condition, so what happened here? Here the holes are majority carriers, and here if you observe the N region, the minority carriers is holes. So here more holes will be there. So high concentration is there in the P region and low concentration is there in the N region for holes. So what happened here? There is a concentration gradient will be present. The rate of change will be there as we move from P region to N region. Therefore, because of the concentration gradient, what happened is the holes that are higher concentration in the P region will move into the N region. Okay, they are trying to move into the N region. Similarly, similar explanation will be there here in N-type material or N region. The electrons are the majority carriers. These electrons are higher concentration, but in P region, the electron concentration is low. Where, at this point, the concentration gradient is also exists. Because of that, the electrons will move from N-type region, that is higher concentration, to the P-type region. Okay, that's what here the diffusion current that will be obtained for us. Okay, understood. So whenever a concentration gradient is there, that means there is a variation in the concentrations at one region to another region, that is higher concentration to lower concentration, then the diffusion process will take place. Here we have two cases. The first case is in P region, the higher concentration of holes will be there. In the N region, lower concentration of holes will be there. Then there will be a movement of holes from higher concentration region P to lower concentration region N. Okay, so that movement of charge carriers that is taking place from P region to N region is called as the diffusion of holes. Okay, so that's what you can observe in this statement. When a PN junction is being formed, the holes will diffuse from P side, that is higher concentration side, to the N side, that is lower concentration. So here symbolically I have represented P to N. Okay, and in the opposite way what I explained, while the electron diffuses from N side, that is higher concentration of electrons that is present in N side, to the lower concentration, that is P side. So in both ways here there is an existence of concentration gradient in terms of holes and in terms of electrons will be there. Therefore the holes will move higher concentration region P region to N region, and at the same time electrons that are present a higher concentration in the N region to lower concentration in the P region. Therefore the diffusion of holes and electrons that will be takes place from P region to N region and N region to P region respectively. Okay, So this is the point how after formation of this junction, if you consider that as open circuited, if you place in at room temperature, so what happened, there is a movement of holes and electrons will be takes place from higher concentration to lower concentration, right, from P to N and N to P, the holes and electrons respectively. That is what how there will be a movement diffusion process will takes place, okay, for an open circuit condition. When a PN junction is being formed, holes diffuses from P side to the N side, while the electron diffuses from the N side to the P side. This happens due to concentration gradient across P and N sides. So I already told that the concentration. What is concentration gradient? Concentration is gradient is nothing but the variation of concentration of charge carriers from P to N. Okay, so that is the point you have to remember here. Okay, so this is the diffusion process that is taking place after formation of the PN junction, right? So we'll move to the next point. Here I have given the heading that open circuited PN junction. Okay, so these holes are moving like this and these electrons are moving like this. Okay, but what happened here, nearer to the junction we have immobile ions, that is negative acceptor ions and positive donor ions. Nearer in the P region we have, nearer to this junction, I already told that here we have three charges, and here also we have three charges. One charger is holes, majority carriers, minority carriers, and at the same time negative ions also present in this P region and positive ions also present in the N region. Okay, so here we have two processes that are taking place here, that is hole diffusion from P to N and electron diffusion from N to P. Okay, hole diffusion from P to N and electron diffusion from N to P. Then what happened if the diffusion taking place? Okay, so here the holes that will move from higher concentration to lower concentration, and these hole can move from this point to this point, and these electrons can move from this point to this point, and they are trying to cross the junction and they will recombine at this point. Okay, and what happened if these charge carriers is recombined, only ions will be there. In the P region we have negative ions and in the N region we have the positive ions. You can observe that this one. Okay, whenever there is a movement of holes from P type to N type, that means they will cross the junction and they in the N region they will try to recombine with the electrons. But the nearer to the junction we have immobile ions, that is acceptor ions, and but the holes that are present nearer to the junction will be recombined, they will nullified, and the only charges that are present here is nothing but acceptor ions in the P region and at the same time donor ions in the N region. Okay, minus and plus. Okay, now we'll see statement wise how it will takes place. Holes diffuses from P to N. This diffusion leaves an ionized acceptor or negative charge on the P side. So these electrons, these holes, whatever we have white circles, those are crossing the junction and they are going to move from this side to this side, and therefore whatever the acceptor ions that are present in this region will be immobile ions, they cannot move. Only holes and electrons will move, that those ions cannot move, they will be wherever they are placed, that will be their position, they cannot move from one region to another region. Therefore all the holes whatever we have at higher concentration, they are moving into the N region, but they will leave that whatever the negative ions or negative acceptor ions here. Similarly in the N type region, the electrons move and cross the junction, but whatever the positive ions that are present nearer to the junction, they will be present, and that is considered as like this: minus is present acceptor ions in the P region, plus is present in the that is donor atoms or donor ions in the N region. Okay, that's what we have to observe clearly. Okay, this is very very important. Okay, so this diffusion leaves an ionized acceptor or a negative charge on the P side as more and more holes start diffusing to the N side. Okay, more and more holes start diffusing to the N side a layer of negative charge. Here you can observe more and more holes are moving from p type to n region. What happened here? A more amount of negative charge will be present nearer to the junction in the p region, and at the same time more number of electrons are moving from n region to p region. There is more number of positive donor ions will be a layer of positive and negative ions will be present nearer to the junction. Okay, so that's what you can observe clearly here. These holes are moving from this side to this side. That means whatever the immobile ions that are present, only they will be present, and the remaining holes will be crosses the junction. Similarly, the electrons that are present here, these electrons will move from n region to p region, and the whatever the donor atom positive ions we have, that will be placed near to the junction. So as this movement of holes is increases, the concentration of holes that are crossing the junction will increases, means automatically there will be a more number of ions and they will form a layer of acceptor ions. You can observe here in the statement, a layer of negative charge or negative space charge region on the p side of the junction is formed. Okay, so this is what you can observe. The blue color negative symbol is their circles. So these are nothing but acceptor ions or negative acceptor ions. Okay. So similarly, you can observe electron diffusion from N to P. So these majority carriers will move from a higher concentration to the lower concentration. So what happened here? Whatever if the concentration of the electrons that are moving from N region to P region, what happened is here they will leave some ionized positive donor ions. Sorry. So as this concentration is increases, moving concentration of electrons from N region to P region, then there will be a formation of layer of donor ions nearer to the junction. Okay, understood. So this diffusion leaves an ionized donor or positive charge on the n side. This donor is bonded to the surrounding atoms and it is immobile. It cannot, these ions cannot move, immobile. As more and more electrons start diffusing to the p side, a layer of positive charge or positive space charge region in the n side of the junction is formed. So combinedly, here there is a negative charge accumulated. Negative charge will be present. Negative acceptor ion charge will be present nearer to the junction in the p side, and a layer of positive donor ions will be formed in the n region. Okay, so this is what after forming the junction. If you take this one to the room temperature, that is open circuit condition, what happened to the next step? First, if you combine p and n type material, there will be a formation of the junction. And if you consider open circuit p-n junction, then there will be a formation of a space charge region that consists of positive and negative space charges. Okay, so this region we called as what? This combination, this layer of negative and positive charge combinedly we called as what? Depletion region. What is the term that is used? That is depletion region. Okay, and another name is there for it. It is nothing but space charge region. What is the term? Depletion region or space charge region. Okay, we can also have here negative and positive ions, so that they will provide some potential that is called as barrier potential or contact potential. What is that? Barrier potential or contact potential. Okay, we'll see in the next coming slide what is the barrier potential. That is up to this point, this is nothing but formation of the junction, and this is nothing but the formation of the depletion region, and its width is around 0.5 micrometers. Okay, the width of the depletion region is in micrometers, right? That is 0.5 micrometer. And the barrier potential, we have that barrier potential is there, 0.3 volts will be there for silicon or for germanium, and 0.7 is there for silicon material if you consider to form a PN junction, and it is 1.12 is there for gallium arsenide. Okay, so this is what formation of the PN junction, and at the same time open circuit condition of the PN junction, if you observe, this is the formation of the depletion region. Okay, so the depletion region will form due to the diffusion process here. Okay, and next we'll move to the next slide here. since the diffusion of electrons and holes across the junction depletes the region of its free charges, these spare charge region together is called as what? Depletion region. What I have indicated here. Together, this acceptor ion layer and at the same time donor ion or positive ion layer together we will combinedly called as what? Depletion region. Okay, so here you can observe this is since the diffusion of electrons and holes across the junction depletes the region of its free charges, these space charge regions together are called as the depletion region. Okay, what I have explained there. The thickness of the depletion region is of the order of 0.5 micrometer. Okay, so the thickness is here 0.5 micrometer. Next one, an electric field develops directed from the P side to the N side. That means what? From negative P side to the N side, an electric field will be developed. Already I told that this negative, that means any electric field is what? A negative and positive charges, positive charge. Okay, here negative will be there and positive will be there. So it will form an electric field or electric potential. Okay, so that potential an electric field develops directed from the P side to the N side of the junction, that is negative to the positive here. So this is the electric field we have. Okay, so an electric field will develops directed from the P side to the N side of the junction. This is because of the positive space charge region on the N side and the negative space charge region on the P side of the junction. So if you consider here, positive is present in the N region and negative will be present in the P region. So that is nothing but the electric field that is given by this positive and negative ions that are present in N type and P type respectively. Okay, this one is called as neutral region, this one is charged region, and this one is N type material. So you can consider the electron concentration here. If you observe that the electrons will move from this side to this side and they become minority carriers. Here the concentration is more, that is electrons, and in P side if you observe the concentration will be less. And if you observe here the concentration red mark here higher position is there, the concentration is more in the holes in the P side and they will cross the junction, and here uh, we have this minority charge carriers. Okay, up to this one there is no problem, that is diffusion of charge carriers is takes place, and due to that some diffusion current will flow. Okay, and at the same time some electric field will be developed across that junction. Okay, at the junction. Okay, so an electric field develops directed from the P side to the N side of the junction. This is because of the positive space charge region on the N side and negative space charge region on the P side of the junction. You can observe that this is what? Okay, electric field. This electric field is responsible for the movement of electrons from the P side to the P side to the N side and holes from N side to the P side. Okay, so if you observe here the electrons are what? Minority carriers. These minority carriers will attracted, that is electrons are attracted the positive potential what we have here electric field, positive and negative electron. These electrons will be attracted towards the towards what we call the positive charge, positive electric field, and at the same time whatever the minority carriers that are holes that are present in N type, those will be attracted uh, towards the negative charge what we have, negative electric field that is produced. Okay, that's what the point here I have mentioned. This electric field is responsible for the movement of electrons from the P side to the N side. Okay, the electric field is responsible for the movement of electrons from P side. Whatever the electrons that are minority carriers from P side to the N side, they are attracted because of what? This positive electric field. Similarly, the holes that are minority carriers that are present in N type will be attracted towards the uh, P region, that is due to the negative electric field. That's what the statement here. Okay, from P side. This motion of charge carriers due to the electric field is called drift. Okay, some people think that here we are not applying any external field. Then how you can get drift current? Drift, actually, the definition of drift current is nothing but if you apply the external electric field, then there is a motion of charge carriers. Then that current is called as drift current. But here inbuilt electric field is the reason for the drift current that are present in this open circuit condition. Okay, inbuilt means what? Inbuilt is nothing but this electric field that is formed, or the here you can observe blue is minus, that is negative ions, and plus positive ions, they can form the electric field, right? This electric field, this an internal electric field that is formed due to the space charge region, due to the depletion of holes and electrons here, that is the reason for the drift current that is present in the open circuited PN junction. Okay, so that's what that is. This is also very important point, because some people think that here there is no drift current because we are not applying any external field, but there is some drift current. That drift current is due to the electric field that is present in the space charge region. Okay, that is developed in the space charge region. Okay, so this motion of charge carriers due to the electric field, due to this electric field, the minority carrier electrons will move from p side to n side. The minority carriers holes from n side to p side. That means movement of charge carriers is taking place due to the electric field, internal electric field that is generated. Whatever it may be, the electric, whatever it may be, internal or external field, but due to the electric field, if the motion of the charge carriers is take place, that is compulsory, we have to consider as a drift current. So here the internal drift current, internal electric field, that is the cause that causes the motion of the holes and electrons from p side to n side, and holes from n side to p side. So this type of current is called as drift current. That is the point I have mentioned here. This motion of charge carriers due to the electric field called drift. Hence, the drift current starts, which is opposite in the direction to the drift diffusion current. So actually, the holes will move from this side to this side. Electrons also moves from majority carriers, so from n side to p side. Then the holes direction is from p side to n side, and the electron direction is holes direction is from p side to n side. So the current direction is from p side to n side due to holes. Similarly, from the electron motion is from n side to p side. So the motion is from n side to p side. The electron motion, the current direction we will consider is exactly opposite direction. So here the diffusion current direction is from p side to n side, but the drift current direction is because here minority carriers are the electrons, these will move from p side to n side. So the direction of current is opposite to the electrons. So n to p, that is drift current. Similarly, the holes will move from n type to p type. What happened here? So n type to p type means whatever the direction of holes, we will consider the same current direction. So the minority current direction, or the minority carrier movement is there from current direction is there from n side to p side, but the diffusion current direction is from p side to n side. This is very, very important. Diffusion of holes is takes place here from p type to n type, that is majority carriers. The current direction is in the direction of the holes we will consider. One current is due to holes, that is diffusion current. Similarly, we have the electrons are moving from n type to p type, that is majority electron current. That is electrons are moving from n side to p side, means we have to consider the direction of the current is opposite to the direction of the electron. Okay, so here electrons are moving, are diffusing from n type to p type. So the direction of diffusion current due to electrons is from p to n, that is opposite direction. So the diffusion current combinedly, the whole current is in the direction of p to n, and the electron diffusion current is also from the direction of p to n. So they will added. So the diffusion current direction is from p to n, but the drift direction is from n to p. You have to remember, this is very, very important point. Okay, so hence a drift current starts, which is opposite in the direction of the diffusion current. Okay, here the drift current is due to the internal electric field that is generated in the depletion region. Okay, that is one point, and its direction is from n to p. Okay, but diffusion current direction is due to concentration gradient, that is from p to n. Both are in opposite direction. Okay, then how much time it will takes place, we will see. Okay, so When the diffusion starts, the diffusion current is large and the drift current is small. As diffusion continues, the spare charge regions on either side of the junction starts extending. Okay, that means one more number of holes and electrons are moving from p type to n type and n type to p type. Then what happened here, more number of spare charge region will be formed. That spare charge region or depletion region is extended and more amount of electric field will be generated. So more amount of electric field is generated, more number of minority carriers will move from p type to n type and n type to p type. Then that will increases the drift current. Okay, so this when the diffusion starts, the diffusion current is large and the drift current is small. As the diffusion continues, the spare charge region on either side of the junction starts extending. This strengthens the electric field and eventually that increases the drift current. The process continues till the diffusion current is equal to the drift current. This is how a PN junction is formed. Okay, this is the last stage of formation of a PN junction. That one we will consider as an open circuit. Okay, so barrier potential. In the state of equilibrium, there is no current in a PN junction. At equilibrium means at what condition the equilibrium will be obtained if the diffusion current is equal to the drift current. In the open circuit condition, that condition is called as what? Equilibrium condition. At that equilibrium, the diffusion current equal to drift current, both are in opposite currents. Opposite currents means they will cancel each other. The drift current is cancel. Drift current and diffusion current both are opposite and equal, so they will be cancelled. So there is no current that is flow at equilibrium condition. Okay, so that is what you have to remember. Another very important key point in the state of equilibrium, when we call this one as equilibrium, whenever the diffusion current and drift current in a open circuit PN junction is equal and opposite direction, then that point is called as equilibrium condition. At that equilibrium condition, there is no current in a PN junction. The difference potential develops across the junction of two regions due to the loss of electrons by the N region and subsequent gain by the P region. The polarity of potentials opposes the further flow of carriers to maintain the state of equilibrium. This is called barrier potential. Okay, so this is how a PN junction is formed and how a PN junction is formed and how we can how a PN junction is formed, how the depletion region will form, and what is the barrier potential, and how the diffusion and drift current will take place, and how the diffusion current and drift current will be equal and opposite direction. And all those things we have discussed till now. This is what about the formation of the junction, PN junction, and at the same time what we call the open circuit PN junction analysis. Okay, so this is what we have. So if you observe here, I have given some statement here. In PN junction diode, basically we have three phases. Okay, the first phase is what? Junction formation, and at the same time open circuit PN junction or the PN junction at equilibrium. So in this one, what we are going to get is where the formation of depletion region, what we have seen, and at the same time built-in potential. Okay, so this is what the first step of PN junction, that is PN junction formation and open circuit PN junction. Second step is nothing but if you make the PN junction is under forward bias and if you make the PN junction is under reverse bias, it is reverse bias. In this reverse bias, we have junction capacitance. Under forward bias, we can also see the VI characteristics of the PN junction. One by one, we will see here. Okay, so another picture you can observe here. Okay, so what happened here? The positive ions is accumulated. If it is N type, it is for the negative ions will be accumulated in the PN junction, PN region, PN junction. Okay, so they cannot allow the holes and electrons, right, on either side. Okay, so you can observe this is nothing but this person is nothing but what? Depletion region. You can observe, and these fishes here we have and here we have, those are what? The charge carriers. Okay, that is P type and N type, that is majority carriers. They will try to move from this side to this side, but this person, that is depletion region, is opposing the movement of electrons and holes from P type to N type. So this is the picturization, pictorial representation we can have for easy understanding. Okay, so up to this point I will stop today.